then what we can do is then we can moderate it that way, and I can read out the question to the panel, and we can go that way with it. So again, once we get started, be thinking about questions for the panel, and when you're ready for them, we call for them, and then just pop them in the chat, and we'll look at that, and we should be good to go. So I think everybody else is here. I want to recognize a few people, Kipper staff that we have on. I know Tim's here. He's the technical guru who's got all this going. He's actually streaming this to our Facebook. So if you have any friends that want to see this, you can send them to Ball Educational Robotics Facebook page, where we're streaming live, and we're also recording this. So we'll have a recording of it. We also have two of our esteemed board members are with us. We've got Ross Mead, who's on the Kipper board, former baller, by the way. And we also have Braden McDormand, who's going to be our keynote speaker. He's also on the board of directors and a former baller. And then our panel, which is very interesting, you're going to notice our panelists selected. These are all former ball participants. So we thought it'd be really cool for you to get to hear from a panel of people that started in ball and where they're at now. And then also Kipper staff, we've got Carol, and Carol Good Game is here as well. And also on our Chinese partner, I see Fred. Fred is here all the way from China. Nice. Fred is here managing the Chinese teams on that end. So it's, big time difference there to make it work. Is there anybody else that I've missed that I looking through the thing? I think I'm good. Don't you think, Tim? Looking good? All right. So with that said, what I want to do first is start with the panel. And so Tim's going to pin the three, but I'll give a quick introduction. But what I've tasked them with doing is, once they get up on the panels, give them a brief overview of who they are, where they live, what they're doing now, and kind of what they did in ball. So first we have Emily Curtis, former ball team player at middle school in Norman, Oklahoma. Totally awesome. And then we have Nafis Zalman. So Nafis is former, software developer for Kipper. Went to OU, and then now, he'll tell you what he's doing now. And then we also have Will Hawkins. Hey, Will. Will is a former Kipper employee as well, and he was also he was on the ball team out of Texas on DeWitt Perry team. So with that said, let's start. And again, I'll give you guys, whatever time you need to take. We've got about an hour here to give the brief introduction of yourself. And let's start with Emily. Emily, if you want to go first.
Sure, yeah. I can go ahead and bat lead off here, if you will. We're going to be talking a little bit about what I do now, which is really heavily baseball related. So had to start off that way. I will say beforehand too, right before we logged on here, I had a really bad case of the hiccups, and I was really hoping that they would go away. Nafis can attest, but luckily they did. Lucky for all of you. But yeah, thank you everyone for tuning in. I'm so excited to be able to talk with you all. My name is Emily, and I participated in ball as a middle school and high school student in Norman, Oklahoma. Was part of the Whittier Middle School girls team, and then briefly with Norman Advanced Robotics, and really enjoyed my time there. And then, so I guess kind of starting from around middle school, high school time, I loved doing robotics, really loved like math and science, which I bet a lot of you all do as well. But also a huge like passion of mine growing up was sports and baseball, and not as much playing. I mean, I played some sports, but mostly I just really, really loved to watch baseball. And I was a huge St. Louis Cardinals fan. I don't know if any of y'all are from that area or follow any Major League Baseball teams. But yeah, I was a huge Cardinals fan, watched the Cardinals with my dad a ton. And, when you're in middle school and high school, you're thinking a lot about like what you want to do in the future, what kinds of jobs you might be interested in. And so I started thinking about if there's any way for me to combine this, like, passion that I had for baseball as with a lot of my like math and science background and the stuff that I loved about math class and robotics and all of that. And so after reading Moneyball, which is a book, and they also made a movie about it as well, if any of you have seen the movie or read the book, I decided, maybe I want to work in baseball as like an analyst. So use the numbers and the data and all of that information in baseball and and kind of use my math and science background as well to try to help a baseball team get better. And at the time, when I was in middle school, high school, I wasn't super committed to that as a path, partially just because I didn't see a lot of women working in sports, working in baseball, and there are so few job opportunities that I really didn't know if that was going to be a path for me. And so I kind of pursued other paths. I went to the University of Oklahoma and got my bachelor's degree in math. And then I went to the University of Washington in Seattle and got my master's degree in applied math. And at that time, I thought, okay, maybe I'll do kind of a more traditional like data science type job. So a data scientist is someone who takes a lot of data and information that organizations have, businesses have, and tries to kind of take that data and turn it into actionable steps that the business can take to make more money or like move toward their goals in some way. And so I thought, okay, maybe I'll be a data scientist. And I remember I applied for a couple jobs as a data scientist when I was coming out of grad school, and I had an interview, and I don't even remember what the company was or the organization. And they asked me to talk about some of my personal projects that I've been working on at the time, and they were all like baseball related. And so like ideas I had about baseball, things I've been thinking about. And I remember just speaking so excitedly and passionately to them about these projects I've been working on. And then they asked me, why do you want to work here? And I had so much trouble answering that question. I couldn't tell them I wasn't excited and passionate about it. And I remember coming home that night and talking to Nafis, who's also a panelist here, and my husband, was not at the time, but is now. And I remember talking to him and just saying, you know what, I really think I need to try this. I think I need to try to work in baseball. And so after that, I applied for a job with the Mariners, with the Seattle Mariners, and I ended up starting as an intern with them in 2018 and have been working with them since. Started as an analytics intern and then was a full-time analyst with them for some time. And now my official role with the team is coordinator of baseball projects, which is fancy for I take data and information and I make it accessible for other people in the organization. So lots of reporting, generating graphics and tables and websites, all kinds of stuff, just to take all of the rich data that we have to help everyone in the organization get better. And so, yeah, it's some of the most fun parts of my job, especially for like our minor leaguers. So if you guys are familiar at all with baseball, there is the team that you see, the major league team. So like the Seattle Mariners or the St. Louis Cardinals or any of the other major league teams. But each team also has what's called a farm system. So we have a lot of players that are training to try to get good enough that they can play with the major league team. And so one of the best parts of my job, one of the things I like the most, is I get to help be a part of this process that we call player plans. And every single player in our organization, from the very lowest level all and to become a major league baseball player. And then I am largely responsible for creating a document that tracks how they are doing on those goals that we set for them over time. So for example, for a baseball player, a goal might be, we want this player to throw more fastballs or throw more changeups, or we want this player to hit the ball harder. Those are kinds of things. We have such an incredible and rich data set as part of, just baseball games and everything we're able to track, that we can see how they're progressing in all these goals that we set for them over time. And so I get to put together these documents that the coach then can go and sit down with the player and say, hey, we set this goal for you. We were hoping that you would be able to hit the ball more, harder, and this is how you've done. And so being a part of that process, along with like lots of other data related processes, has been really, really fun for me, something I've really enjoyed. And yeah, I guess, I've been talking for long enough here and would love to pass it to one of the other panelists, but I'll close by just saying that a lot of people often ask me what my favorite part of my job is. And I always say that my favorite part of my job is helping other people make better decisions. So I don't like to make the decisions myself. That makes me kind of anxious or queasy, very nervous to make a decision, and I'm worried that I'll make the wrong choice. But what I really, really like to do is take all the data and information that we have available to us and collect it and share it in a way that helps someone else make a better decision. And yeah, I think that's all I have for now. I'm happy to answer any questions that y'all have. Hopefully we've got some baseball fans in the audience, but yeah, that's what I do.
Perfect. What a great story, right? From robotics in middle school all the way through college and loving baseball and kind of putting computer science and math and everything together. It's fantastic. Yeah, if you guys have questions, be thinking about them and be getting them ready for the chat. I think we'll move on and we'll move over to Nafis. You go ahead and give your introduction.
Yeah. So my name is Nafis. I did ball for 4 years in Oklahoma, where I grew up, and 2 years at Whittier Middle School and 2 years at Norman Advanced, same schools that Emily went to. And I know you all are all in ball and probably have a lot of good memories from tournaments and things. So I was thinking about what kind of my favorite moments were from my time in ball, and two that always come into my mind. The first is my 8th grade year. I think it was 2009 Oklahoma regionals in the final. Emily's shaking her head because she remembers what happened. We had our Whittier boys team and Whittier's girls team up against each other in the finals, and that was a lot of fun. And the other one
I appreciate you not saying who won that.
We don't need to talk about it. It's okay. And the other one was GCER in 2011, which was my last year in ball with Norman Advanced. And it was in LA, just a lot of fun there. And we had a couple robots I really liked, like one that did some really cool cube stacking and seating that was a lot of fun to work on. And I would have done ball another 2 years, my junior and senior year in high school, but I went to a different high school in Oklahoma that did not have ball at the time. They do now, which is awesome to hear, and they participated in a few of our other tournaments this year, I know, but they didn't have a team at the time. And so in ball, I was one of the programmers on those teams, and it was my first exposure to programming and really engineering at that of that kind, like not doing math problems or science problems or something in a classroom, but actually getting to apply those things. And I think it just really clicked with me. I loved getting to write code and try things and see it fail and figure out how to make it work, and just got a lot of satisfaction out of when you know what has to be done and then you do it and it works. It's really satisfying. So that convinced me to kind of continue and take as many computer science classes as I could in high school, and then ended up doing the same thing in college. So I also went to the University of Oklahoma for my undergrad in computer science, and during college I ended up working at Kipper for a couple of years as a software engineer, as Steve mentioned. So I got to work on things like KISS IDE and the controller software at the time. And that's still probably one of the coolest and most rewarding moments of my career, because getting to work on, getting to use that software as a student for 4 years, then getting to contribute to it for other students to use was awesome. And then during college, I also did 2 summer internships after my first and second years. One of them was at Fidelity Information Services, like a financial tech company in Oklahoma City, as a software engineer. Just getting to work on some financial tech software. And then my second one was at Microsoft near Seattle, where we live now. And that actually led to my current position. I'm a software engineer at Microsoft in Redmond, Washington. Much less fun, more boring than being a baseball analyst. But for most of my time here, I've been on a team that's kind of like consulting. So we worked with a lot of other companies that use Microsoft stuff and try to help them solve whatever their biggest problems are at the time. So some cool examples I was trying to think of over the years. One of my first ones I got to work on was in partnership with Microsoft Research. We worked with PSG, which is a big soccer team in France, using machine learning to better understand kind of their fan engagement in stadiums and help improve that. Another cool one was working with McDonald's. They were, and I think other kind of fast food companies as well are trying to really make their drive-throughs in particular more efficient. And so we worked with them on how they can like automate their drive-throughs using voice recognition and language understanding, and just make the experience better for both ends of it, both people in the drive-through and people working the drive-through. And then last year, everything kind of shifted a bit, of course, with COVID. A lot of companies were kind of undergoing transitions, and there was a lot of health related projects. And so one project I got to work on was with a research team at Stanford, who was providing at-home COVID tests to people in the Bay Area and conducting COVID studies to better understand how it was spreading. And so I got to work with them on the software for that research team. And then also worked with just a bunch of large healthcare companies that were working on how they can conduct doctor visits with patients, like annual checkups and COVID tests, like at-home tests and things like that, virtually. So we came up with ways they can do that in super cool ways using Microsoft Teams, and how to make that as quick and easy as possible for patients. That was also a pretty fun role because, working with all these companies, sometimes they would meet us here, but I would also get to travel quite a bit. So I got to travel in the US to like Boston was the first place I went, but also to LA and St. Louis and Austin. And then internationally as well, I mentioned, the PSG in France. I got to go to Paris, London, Tokyo, Toronto, Stockholm. So over 5 years, I got to go to a bunch of really cool places. And there were work trips, but it's still fun to get to see those different cities and work with people internationally. Really was something I had never done before. And very recently, just in the last few months, I switched to a different team at Microsoft within Office 365, which is the cloud online version of like Word and PowerPoint and all those tools that we all know and love, or at least know. And so it's been fun getting to kind of try something new, try a different side of the company, and learning a lot of new things. And then aside from Microsoft, I'm still working whenever I have time, working with Kipper on some of their software, like the upcoming simulator and some things like that. I think that's pretty much it. I probably took more than my time slot, so I'll let Will go next.
It's okay. I'm not sure how I can follow these two.
Oh, you got it, Will. Go. You're good.
So I started out in ball in middle school at DeWitt Perry, and I kept doing that through sophomore year of high school at R.L. Turner. After that, I went on to another high school that did not do ball. So when I was in ball, some of the most exciting things to me was actually the building the robot and trying to get all the mechanical parts working just right. But it turned out when I went to college and I started that mechanical engineering degree, I had one programming class that was mandatory, and that just suddenly clicked really well, and I knew that was what I wanted to do. So I went off into the programming, got to work on a lot of projects. I actually ended up finding out Kipper was right next to OU. I didn't know they were there. So I did get to work with Kipper and got a lot of experience in a lot of different things. So some working with the hardware, trying to figure out things. So I'm responsible for all the green dots that you saw on Wallabies. Then some just making sure all the parts from the kit come together. And I got to learn a lot more about how the other stuff that software touches works. So when I was out applying for jobs, I actually got a lot of really good feedback on knowing more than just narrow tunnel vision on software. If you have all this context, all these other areas, that's really great. So now I'm working for Epic Systems in Wisconsin. They make medical record software, and I'm specifically working on our coordinated care management platform, which that's all of the stuff outside of traditional healthcare that we can help out with. So Finland uses it for their social services. We get to do all sorts of stuff with a lot of programs in the US for a lot of different reasons. Recently, I've been working on just gathering all the data that we have in our system and trying to format that in more readable ways, making timelines, making other visualizations. And I've got to work with a lot of different teams across the company because we are touching all the different areas.
Very cool, Will. Very cool. So what's amazing to me is what we have here is we've got guys who did robots and did all the stuff. We don't have anybody working on a robot. We have somebody working on baseball data and analytics to improve team performance. I mean, who would have thought of that, right? I would have never thought of a career like that in middle school. And then I think Nafis and Will kind of a more traditional route, but software development, but the projects they're working on just sounds phenomenal, right? Like trying to figure out what's, how to track COVID and make it better, and how to make doctor visits better. It's all software related. And then Will as well, working on software systems for healthcare. I mean, it's really great that we've got all of those things in. It's amazing. So anybody have questions, now's a good time for question and answer. And I already know the first one. Yes, Emily's job seems way cooler than Office's job. That's all there is to it. And I'm guessing you get tickets to all the games, Emily, is that?
I do. I get 4 tickets to every home game. So if anyone's coming to Seattle and wants to go to a Mariners game, let us know. But yes.
That's pretty cool. All right. So one question I have, and please, everybody else watching, now's the good time to put your questions up into the chat. So I'm not asking them all, but what would you tell a student now? Let's say they're in Bob Ball, either middle school or high school. What would you tell them that skills to work on that are going to be more valuable? And not so much maybe in getting a job, but more in the work that you're actually doing now. Because they always tell you in school, you got to learn this because you're going to use this in your job. I don't know if that's true or not. So what skills do you think are the most valuable for our students to try and acquire now that they're still in middle school and high school before they go to college and enter the job market? And anybody can just jump in on that one. I know it's a tough question.
I can go first. Yeah, so I get the question a lot from folks who are interested in like getting a job in baseball. But I think some of the advice that I give relates really well to like, having success in your job or how to be a successful baseball analyst or anything really. And I think the one piece that I always advise students is developing a really strong sense of intellectual curiosity. So I think the best people in their jobs, in whatever your job is, are the people who like every day are trying to get better. And I think as far as getting a job as well, I mean, I am not involved in hiring every position in the world, but I know the positions that I'm involved in hiring, I always really look for folks that I can tell like, okay, this person is curious. This person wants to get better. And I know that like their skills on day one are not going to be the same as their skills like a year into the job. And so I think that's something that matters a ton. As far as like specific skills, I think some things that have been really useful for me in my job, just having a question and being able to try to answer it. So honestly, Nafis has helped me a lot with this, but like really good Googling skills, I think are super important in any kind of like coding or software position. So, asking the right questions, but also like being skilled at finding the answers to those questions, I think is really helpful. Persistence, of course, and intellectual curiosity are the ones that come to mind immediately for me.
Fantastic. Nafis or Will, something else to add to that?
Yeah, so let's repeat what I said earlier. Just having some more context into the area is really hugely important. Some of the best people I work with, smartest people I work with, they can just say what the doctors are going to say without having to do a ton of research. They just know what's going on. So if you can know the area you're working in and be like, not just I am a coder, I do code, that's what's going to set you apart. That's what's going to make the huge difference in what you can do.
I just want to very quickly second that as well. I think that matters a ton for my job. Like, yeah, a lot of what I do is like coding and generating reports, but I think it would be really difficult for me to do it if I didn't have a really deep understanding of baseball and how it works.
Awesome.
Yeah, I would definitely second the curiosity thing. Like, I think all of you are already taking time, you know, outside of school and the afternoons, on the weekends, whatever, to participate in ball and learn new things, and just keeping that curiosity going, and really exploring whatever interests you the most, even if it's not related to like engineering and math, whatever really makes you wonder and ask questions like, oh, I wonder how you do that, or I wonder how that works. Those are the things that you'll feel most engaged with, I think. I think the other thing that has, I think I still struggle a lot with, I think I've gotten better, but has really been important is communication. Like being able to come up with a solution to a problem is one thing, but then being able to actually communicate that to others, explain things in an organized way, will help you pretty much no matter what you do in the future. I think programmers in particular kind of have the stereotype of like working solo, being lone wolves, and like you slide pizza under the door and a few hours later out comes code and that kind of thing. But even programmers work with other people. They have to like communicate bugs to other programmers or talk through solutions. And like I said, I struggled with that a lot, especially in like larger public settings. But the more you do it, the more practice you get, the more comfortable you become. So, you know, it's something you get better with experience. So any opportunities you have to present to even a few people or anything like that, I think is a great idea.
Yeah, I like that. It's people skills. I mean, the technical skills are something, but without the people skills and the collaboration, it just doesn't go. That's fantastic. A couple of questions off the chat. I see some in there. This question is, what's the most difficult aspect of your job? So let's say, pick one or two of the things that are just the hardest part of your job. And go ahead, Emily. We'll start with you. We'll just go the same
Sure.
order.
Yeah. A couple things that come to mind. First, actually, Nafis's point about communication, I think, is so important and something I deal with a ton. And I think that can be a really difficult part of the job, is just, and something that I've gotten better at over time. It's also, I think, one of the most fulfilling parts of the job. And I know Nafis was talking about this moment when like your code finally works, that is like really fulfilling. And I think for me, I get that feeling when the person that I'm talking to like finally understands what I'm trying to communicate to them. I definitely get that kind of like, ooh, that feels really good moment when I'm talking to like a coach or someone and they kind of grasp the content. So I think communication is definitely something that I work on a lot and that you can continue to get better at. I think specifically more of like a technical difficulty that I deal with a lot, and that we deal with in the baseball world, is one of the projects that I worked on quite a bit before moving into my current role was predicting pitcher injury. So we're building models to try to predict for Major League Baseball pitchers when they will get hurt, which is a very difficult thing to predict. And one of the biggest difficulties for that is, I think, not having enough data or the data that we want, and then being able to kind of like communicate uncertainty. So especially with models, when I don't have a clear answer, I can't say like this person definitely is going to get hurt tomorrow or whatever. That's just not something that you can say. It's always like, this is the likelihood that they'll get hurt or whatever. And I think, you know, being able to trust the process that you've done, even if it feels like, you know, you don't have as much data or information as you'd want. And then when you get a lot of questions about like, what is the answer? Is this person going to get hurt? Is this person not going to get hurt? You know, how, from folks that may not understand the content as well, I think communicating uncertainty is a very difficult thing. And I think a lot of folks that do any kind of like modeling or data analysis, that comes up a lot for them.
Yeah, novice.
I guess I'll give two because my previous role was pretty different than my current one. In my previous role, I think the hardest part again was like essentially communication. Like anytime we worked with different customers, the amount of time and effort it takes just to get everyone on the same page and to get like a common understanding of what the problem is, what needs to be built, how we should build it and everything, takes a lot longer than you would think, but is super important because the worst thing that can happen is you aren't on the same page as everyone. You spend a month working on something and realize that it's not what the customer wanted at all. It's not what you were supposed to be doing. So I think that was tricky and time consuming and frustrating at times, but definitely worth it in the end. In my current role, I think I haven't been here long, but the thing that's been hardest is how do you like I said, I'm in Office 365 now, which is like a massive project with like thousands of people working on it. And it's like, how do you make changes and add features and fix things without breaking everything else that is already there? Is like, you know, I might be writing a small piece of code, but how is that going to affect everything else that's already there? And how can I make sure that I don't mess things up for all the people that are using Office right now? And it's kind of overwhelming and kind of scary. But that's honestly one of the reasons I decided to join this team, is because I wanted experience with that kind of stuff.
Wow. Interesting. This is crazy. I never thought about that. Yeah, you make one change and mess up 900 other programmers or what they were working on. It's a big project. That's a lot bigger than just getting a bot ball robot together to compete, isn't it? Yeah, a lot more massive. All right, Will, what do you got?
Yeah, I'm actually going to say something kind of similar to Nafis. So at Epic, one of the things we do is the developer kind of owns the whole process from initial requirements to all the way to getting the finished product out. So a lot of time is spent at the very beginning in just making sure we know what we need, making sure everyone is in agreement, and coming up with that broad system design. A lot of times it's harder than actually getting it down into code. So a lot of that on the front end. And also, as an earlier career programmer, I keep finding new areas of code that I have not touched before. And especially when it is like Epic or like Microsoft, where we have thousands of developers and tens of years of code built up, it can take a while to get familiar enough to know what your change will actually do, like a few thousand files away from where you're touching. So a lot of the planning that goes into before making a change, and then the execution is not nearly as hard.
Interesting. That sounds a whole lot like it. Plan really well and then go to it. Sounds like I see a lot of bot ball teams that don't do that. They just build everything, throw it together, and then try and make it work without planning ahead of time. So this could be a good lesson, a very good lesson. Plan really well and figure out what everybody wants, and then go. Interesting. So looking on the chat, I've got this one's directly for Emily. It says, Emily, would you ever work for another team? Well, I know the answer is going to be the Cardinals, right? You'd work for the
Oh, that's funny. I really have loved my time with the Mariners, and I'm not planning to leave the Mariners anytime soon, but I will say I would be open to working for another team, and certainly would be open to going to the Cardinals. But we like Seattle, so I don't know. Nafis, I saw you on mute. Do you have other feelings?
I was just gonna say, you were telling me the other day you want to work for the Cubs.
I never have said that. I never would say that. Certainly not. I mean, I think it's hard. You grow up rooting for a team, and then it's like, okay, now all my time and devotion is focused on another team. Luckily, they're in different divisions, so I don't have too much conflict. But I think I could be convinced to work anywhere.
Right. So Ross is saying go Cards. Ross means obviously a Cardinal fan, and he says boo Cubs. So there you go. I kind of knew that since he's from the St. Louis area. I knew that had to be what it was. So anybody else have any other questions they want to throw up in the chat? We've got about 10 more minutes here to go. Or I'm waiting for a comment there. And if not, I can ask one. Or is there anything else you guys want to, any advice you would give? It's been a while since Bob Ball, but any advice you would give these kids for next season when they're getting ready and planning their team and trying to, put this whole big project together to go and compete? What's the best advice you would give them? And let's start with Emily again. I know.
Oh man. Yeah, that's tough. I think, some of my favorite parts of bot ball were, of course, like, interacting with my teammates, having that kind of like collaborative atmosphere. And so honestly, I mean, I think of course the objective is to do as the best that you can, in the competitions and everything. But I think any advice I have would be more focused toward like having fun with what you're doing. Of course, like I think it's super important to enjoy the time that you have and the time that you spend with your teammates. And I think some of my most favorite bot ball moments, when Nafis mentioned that before, I was thinking about my favorite bot ball moments as well. And maybe my favorite moments were not necessarily doing things the way that a lot of the other teams did and trying our best to do it better than they could. But I think the best moments that I had when I was in bot ball were when we decided to do something differently than a lot of the other teams did. And so, I think maybe when you're planning and you're thinking about what's the best way to do this, rather than thinking about what's been done before or, how you can improve on something you've done in the past, just kind of start from ground zero and think like, okay, clean slate. What is the best way to achieve our goal? And maybe it isn't the super technical or like difficult build or difficult, programming. And I know Nafis is nodding because he's remembering the Whittier Middle School robot that just put its arms out and scraped all of the points to one side. But maybe it's not the most complicated, but just taking a step back and not being affected by all that other stuff, I think is the advice I would give.
Yeah, I like that. No offense, Nafis, but I always rooted for the Whittier girls over the boys. Always. Sometimes I had to turn my face
2009
around.
wasn't your year then.
I just had to turn my face away. Sometimes I was smiling so big because the girls often put a beat down on the boys, and it was always awesome. I loved it. Very cool. So, Nafis, any advice you have?
Yeah, I think there's often this focus, like as soon as you see the challenge or something, you want to see like, okay, what are the biggest point items? Like, how can I get as many points as possible? How can we score everything on the board? And if you can, great. But oftentimes, like, I think you try too much and it ends up being like, you end up being a lot less consistent. And I think it's also kind of less satisfying. Like if you try to do something kind of complicated, like Emily was mentioning, it might work once and that's cool, but I think it's really satisfying to be able to do maybe one or two things and do them really well. Maybe do that one thing better than anyone at the tournament did. And like it can just be scoring one thing on the board, but if you do it consistently and if you do it in a cool way that was fun to do, I think that's a win. Like I'm specifically thinking about one robot we had at Norman Advanced in the year where there was the rubber ducks that you had to line up on the line, and we just had one robot that didn't leave the starting box. It didn't even drive, like it didn't have wheels on it. It just sat there and had an arm that went and picked up one duck at a time and set them on the line. And that was one of my favorite robots we ever made, even though it didn't leave the starting box, or it didn't move anyway. Yeah,
I remember that robot. I definitely remember that.
I'll say very quickly too, like very related to that. I remember I was in middle school still that year, with Whittier, and we did something that I think plays really well into my point as well. Rather than like programming a robot to pick up one deck at a time, we had a robot that had rubber bands and just plopped down on the heads of the ducks and moved them onto the line. And so like just thinking about doing things untraditionally, I don't mean to one up you here in office, because your robot did a very great job as well. But I think, thinking about doing things untraditionally, if you don't have to build and code a robot to pick up the ducks one at a time, why not just put rubber bands on your bot and do it all in one movement? Anyway, that was all I had to add there.
Awesome. Yeah, the Whittier girls almost always up the Whittier boys. It's okay. It's okay. We can say. Will, what kind of advice would you have for them?
Yeah, so it is always good to use the KISS principles, try and find the simple solution. What's the best simple way to get points? But don't let that stop you from trying. So I know sometimes we got so focused on what are the points we can get. And then I'd go to the tournaments, and we have the Austrian team with a crate robot that drives up to some stuff in the middle of the board and just starts climbing it. And they looked like they were having so much fun with that, and it was totally impractical and took all their time, but that was so cool, and everyone at the tournament probably remembers that robot. So
yeah, I remember that. Yeah, I'm with you. I saw that robot. That was the coolest robot. I don't think it scored points ever in competition. But man, when it finally climbed the one time out of 20 attempts, it was so awesome.
Yeah, so might not win you the tournament by doing the coolest thing, but that's going to be your memories.
Yeah, gotcha. Okay, so now this question's coming from a Chinese team. What's the most valuable lesson you've learned from your experience with robotics? Most valuable lesson you've learned? We'll jump back to Emily. Put her on the spot.
Sure. I think the most valuable thing I learned was definitely like just the trial and error process. I think about, sometimes there are opportunities to learn stuff like that in school, but I think a lot more often it comes when you're actually just put in a process like this in ball, or like what we experience in our jobs for sure is like, it doesn't always come on the first attempt. It isn't always, your first plan and you execute it and it works perfectly. A lot of times you try something and it doesn't work, and then you try again. And I think just going through that process, being frustrated, iterating, going for it again is something I definitely learned from ball. And I remember now, even my job, there's a line that Nofis always tells me when I get really frustrated. He always says to me, there's never been a bug you haven't fixed. There's every time you catch it, you never just leave it. You always find an answer. And so I think I definitely carried that. That's something that I started to be kind of exposed to in ball that I think about and is really useful for me in my job now.
Awesome. Nafis?
Yeah, kind of also the trial and error was the first thing that came to my mind. And in that trial and error process, learning to fail fast and not get drawn into sunk cost type of thinking. If you try something for a month and it's not going anywhere, don't spend another 2 months trying to fix it or make it better. It's okay to say, we had this idea, it didn't work, let's do something else. And in the end, you'll be happier and you will have tried 2 different things, and that's okay. You still learned something from the first one, and that'll help you improve on your second go.
Yeah, I like that. Will, what are your thoughts?
Yeah, and one of the things that I really took away from having robots specifically to work with was just, it is so much easier to think about what the program's doing and what's going on in the computer when it's happening in real time on something you can see. Because I know with all the different places where I tried to learn programming, I click the button and it's done before I can blink. So that's really hard to understand, really hard to think about. Just seeing it move and taking the opportunity to sort of step through the process as it's doing it, that made it a lot easier to understand what's going on.
Awesome. I like that. Physical computing. That's good. I like what everybody said. Failure. Basically what Nafis and Emily said is failure is a good thing. And by the way, it's going to happen. Don't let it get you down. It's just the way the real life is. You get failure, you back up and go at it again. So you learn a lot from when you fail. And yeah, I would agree with that a lot. So very good. So I'm looking, I don't see any other questions. Let me see if any of my board members, Ross, do you have any questions you would like to ask, or Braden? Any specific questions? If so, put them up in the chat. Or Tim as well. Because, you know, they may be holding off because it's, you know, we're letting the teams ask questions, but I want to make sure they get a chance too. So if you guys have a question, that would be great. So I got one for you guys while we're waiting to see if something else dropped. Who has the best winters, Seattle or Wisconsin?
Having never been to Wisconsin, from what I know, I would imagine Seattle, but Will can tell us if Wisconsin winters are actually quite pleasant.
Right.
I mean, you get used to it. You get used to it.
Right. Very cool. How about Carol? Carol, do you have any questions? You don't ask. Ross chatted in and he said, no, I would definitely second this. Fail is okay. Failure is okay, because he said, yeah, that's how it is. There's lots of failures before you get the successes. So yeah, I always laughed. I was laughing about Will because Wisconsin to me is just cold and snowy. And I know Seattle's probably rainy, but not snowy and too cold. So those are all good things.
We normally get 1 or 2 snows per year, but I think we broke a record either last year or the year before. In January, it rained like all but 2 days.
Oh, wow.
So yeah, I mean, I don't know. I wouldn't want the snow, but I wouldn't want the rain either.
Right. Gray and overcast. So, okay. So it looks like we don't have any more questions. Really want to thank you guys. And by the way, all
think
3 of these.
Braden had one.
Oh, did Braden have one? I didn't.
Yeah, Braden had one. We can.
Oh, I'm sorry. I missed it. Oh, great. Yeah, Braden, great question. So why are you still involved in Bot Ball to this day? Why are you still giving back, basically? Because, you know, Bot Ball's a nonprofit. We leverage all the help we can get, all the volunteer help. So great question. Go ahead, Emily.
Yeah, that is a good question. I would say some of my very favorite parts of the job that I'm in now are getting to talk to students and helping other students who are potentially coming up get into positions like mine, or to do you know, what they want to do and jobs that they want to do. And so I think for me, you know, being involved in Bot Ball is a lot about that, just remembering what it was like for me when I was a student, and all of the resources that Kipper and other programs that I was a part of just kind of helped me get to where I am now. And I definitely want to do the same to help other students get into wherever they want to go.
Fantastic. Nafis?
Yeah, I think just knowing how many students every year Bot Ball has helped give them kind of the first exposure to, could be programming, it could be building or engineering, or really it may be just like any team activity. I am very motivated to help Bot Ball continue to do that. I know it was a huge factor for me. I mentioned like it was my first exposure to programming, and there's not really that many other opportunities for a middle school student and now elementary school students to get their hands on something like that.
Right.
So yeah, I think and like I mentioned before, it's also like selfishly very rewarding to be able to kind of give back and help out you know, on the software and on these tools that that I used to use myself.
Awesome. Will, what's your viewpoint?
Yeah, so when I was in middle school, and actually before that, Bot Ball was just the coolest thing ever. I heard about it in like 2nd or 3rd grade and was just counting the days until I could get my hands on the robots. So I really like the fact that I can volunteer and help contribute to other people getting that experience and getting that hands-on time. And also recently, when I have made a few small commits to the simulator. That's been really cool, working with some other frameworks and other stuff that I don't normally get to touch in my job. I wouldn't touch a game engine at Epic. And now I can say I've at least done something in a game engine.
Great. So fantastic. So again, I was going to point out, right, you know, as we're kind of wrapping this up, all 3 of our panel members here are actually been judges for us, and you'll see them judging again. So they're going to be our judges for GCER as well. So they're still giving back. We really appreciate it. And, you know, one of the things when they left ball, we still, I guess Will was there when we were doing the elementary, but with the expansion to elementary, what you guys were picking up in middle school, we've now got about 50,000 kids that are getting this in second, third, and fourth grade. So they're even getting it at an earlier age, and we're just excited. And, you know, we couldn't do it. We couldn't do it without the volunteers and all the hardworking, you know, you guys are fantastic. Give back and help. We truly appreciate it and help. And that's kind of what Bob Ball is. It's like a big family of, you know, it's kind of a family event, and we appreciate all the help. So when you guys see them tomorrow, you can say thank you, but you know, you're still setting up your robots quickly and ready to run, but you will see everybody there judging your events tomorrow. And with that, I'll thank you again, panel. Thank you for donating your time and presence to be here. And we really appreciate everything that you gave, all the feedback, and it's fantastic. And so next we're going to move on to our keynote, and our keynote is interesting. Yeah. Bye, Emily. Bye. Thanks. And you can go when you want to stay for the keynote. And Nafis and Will. The keynote is going to be given by one of our newest board members at Kipper, but he also could have been on this panel because he's a former Bob Baller. Okay, so he also played Bob Ball and then also worked for Kipper as a developer for many years, and then went away to college on the West Coast, and then eventually went out and don't want to give, you know, the whole story away, but has a startup company, and he actually is working in robotics, which is kind of cool. So not to steal too much of Braden's thunder, I want him, he'll give a little background on where he's at. But Braden, if you're ready, without further ado, we'll get going with this.
Yeah, let me start up the screen share.
Awesome.
Okay, can you see my screen?
Yes, yeah, you betcha.
Okay, and I think there's a way to share audio. There we go, perfect. Awesome. Well, thank you for that introduction, Steve. The title of my talk is Let's Build a Social Robot. So by the end of this talk, the goal is that you will know exactly how you can go about building what we call a social robot, and we'll go into what those are and how you could go about thinking about them. So my name is Braden McDorman. I'm the co-founder and CTO of Simia. Let's see, my next slide is not working. I'm currently based in Los Angeles, California. I'm co-founder CTO of Simio. It's a robotic software startup. I'm on the Kipper board and the technical advisory committee, and I'm a Kipper volunteer. So I've judged for many years, instructed a little bit in the SoCal region, and I'm a contributor to a lot of the software that is written by Kipper. I enjoy long walks on the beach. That's actually not true at all. I live about a mile from the beach, and I've been once for a total of 5 minutes. But that's beside the point. I was born and raised in Norman, Oklahoma, so there's a lot of overlap with the panelists that you just heard from. In fact, Nafis, myself, Emily, we've all known each other since we were very young. So it's very cool that we're all still involved. But in fourth grade, I started programming. I wanted to make a video game, and one of my family members actually had taken an introductory programming class in college. So they knew the basic terms, you know, what could you search for on the internet to get started? And that was enough to kind of start my journey into programming. In sixth grade, I heard an announcement over the intercom saying that there was this after-school activity called Bop Ball. And I checked it out. I fell in love immediately, and I played that for 4 years. In high school, I went to the Oklahoma School of Science and Mathematics, also known as OSSM. Also the same school that Nafis ended up leaving for in 11th and 12th grade. And this is a 2-year boarding school for students in Oklahoma, completely free of charge. If you are a student in Oklahoma, and I know there are some in the call, you should absolutely apply to the school. It's very much a military academy style of education, but it is absolutely worth it. You will have access to some of the best education anywhere in the country. So that was a great experience. And during that, I was also doing a software engineering internship at Kipper, which is totally against OSSM's rules, but they never found out, so that's okay. After that, I got my bachelor's in computer science from the University of Oklahoma. I had a scholarship to stay in the state. I could stay close to family, and I could continue working at Kipper. So it was a no-brainer in my case to stay in the state. During my undergraduate degree, I had an internship at Microsoft and Walt Disney Imagineering in particular Walt Disney Research out of Carnegie Mellon University. So that both fantastic experiences. After my bachelor's degree, I left for my PhD in computer science at the University of Southern California with a focus on robots that help people. And then I left the PhD program after 2 years to focus on Simio full-time. And for all of my childhood, code was a passion. I spent all of my time programming growing up. It took priority over sleeping, over eating. It took priority over school. I almost had to repeat 7th grade. I would skip school to program. And I hesitated to even put this bullet in the slides given the demographics of the audience, but please kids, do not skip school. And the thing I love about coding is that it's pure and unconstrained creativity. No matter what you can think up, you can write code that will do that thing. You're really only limited by the speed of your computer. And I'm totally fine programming for code's sake alone. So, many people when they code have an objective like a product or some utility. I'm totally fine just writing code because it looks beautiful. But code was also an escape for me. And I felt it was important to put in this slide because many people struggle with mental health and mental illness in their families. And we need to be open about discussing these things. So there was a lot of family instability when I was growing up. My father had bipolar disorder and was an alcoholic. And in retrospect, everything felt out of my control. And code is absolute perfect control over a machine. So I was absolutely addicted to this type of control I had over this box sitting on my desk. So this talk will be divided into a few segments. First, we'll talk about Simio, which is the company I co-founded. Then we'll define what a social robot is, why robots are challenging to make, and I'm sure many of you already know some of the reasons here, but we'll enumerate them. Finally, how do we make it work? So, I'm an engineer. I don't want to just show you some robots. I want to tell you exactly how those robots work. So we're going to go into some nitty-gritty technical details. Then I'll have some closing thoughts, and finally, there'll be time for some questions. So first, Simio. A social robot is a robot that can interact with a human on the human's terms. Basically, there's a few possible definitions of what a social robot could be. But this is one I like. So, like when you're interacting with a computer or even a smartphone, you're having to use that computer's interface, the keyboard and mouse, the touch screen, whatever it might be. That machine is not adapting to you, you're adapting to it. So a social robot is exactly the opposite of that. This robot's going to use natural language, which includes speech and body language. And it's going to observe social and cultural norms while doing so. So in certain cultures, being very close to someone while you're speaking to them might be totally okay. In other cultures, definitely not. So the robot needs to understand these differences and reason about them. And finally, very important as well, is that this robot can interact with a human in human spaces. These aren't big industrial robots that are in a cage somewhere in a warehouse. This robot needs to be able to navigate through your home, reason about the objects in your home or office. So it's a much more challenging problem than just putting a robot in a cage. Back to Simio really quick. It was founded in 2015. By the time I'd already left for the PhD program. And right now, creating a social robot is incredibly time consuming and thus expensive since time is money. And we are a B2B company. What that means is that we don't really sell products to end users. We sell products to other businesses. So Simio is making it easy for other companies that are building social robots to do so without reinventing the wheel. And this is kind of based on 3 pillars inside the company. One of them is the operating system. So this is a common environment, a common platform for robots of all shapes and sizes. A robot manufacturer can just load up our operating system and get on the ground running with their robot. So you could consider this the Microsoft Windows or the Android for Androids. So, it's just a general purpose platform that handles a lot of that low level detail for you. The second pillar is developer tools. So these are tools that allow content creators, which are typically not programmers. They could be screenwriters, animators, creatives that need to not only test content and create content for the robot, but also deploy that content. So we provide developer tools that allows those individuals to easily and rapidly create that content and test it and deploy it and refine it further, all that. The third pillar is the app ecosystem. So this is a store of sorts, like the App Store or Google Play Store on your phone, that allows developers to ship their creations to end users. And Simio, it's very clear to reiterate this, does not make robot hardware. We don't build any robot ourselves. We just make robot software. Simio's primary product is called Aurora. And this is Simio's developer tools and on-robot execution engine, which we consider our operating system for now. Our developer tools run entirely in a web browser, so there's no software to install. You just go to our URL and you can connect to your robot and start creating right there. And these tools allow you to create interactive human-robot dialogue, so conversational back and forth, speech, animations, annotating maps and other resources the robot might need to reason about, and more. And this is just kind of an example of the dialogue, or what we call the flow editor inside of Aurora. So this might be an example of something that a content creator would write. This starts out with, if anyone on Twitter mentions the user's handle, so the user might have a Twitter account that's linked up to our system. And whenever someone mentions that person on Twitter, then the robot will say, someone just mentioned you on Twitter. Would you like me to read it to you? And then two things can happen. We're going to wait for one of them to happen. One of them would be the user said something like yes. So if the user said yes, then we're going to read that tweet aloud back to the user. If the user said something like no, then we're going to say okay and wait for the next Twitter mention to come in. We also have an animation system. So this is an example of the SoftBank Now robot executing both inside our web tools and physically at the same time. So we're connected to that robot. And this is an example of face animation inside of our tool. So many robots have screens or other projectors on them, basically virtual bitmapped faces. So our tool also allows you to edit those faces in real time, just like they were physical joints. So this robot obviously doesn't exist in real life, but it does show you a pretty cool example of what you can do with the tool. So Corey, which is the robot you can probably see behind me, is kind of Simio's first full robot. So this robot runs exclusively Simio software. And it's a collaboration between the University of Pennsylvania, Simio, of course, and the University of Southern California. And this is primarily designed for human-robot interaction researchers. So individuals that are in a lab that might want to run experiments with participants. So in the next few months, this is going to be being shipped out to universities like Stanford and others. And we're very excited for that to come. Now, robots are challenging, and I'm sure this is no surprise to anyone that's played bot-ball. There's a lot of things to consider. Software, of course, is always difficult. There's hardware and electronics, so both can be very fickle and difficult to get right. There's mobility, so moving around the environment, and there's manipulation, picking up and grasping objects. There's sensor and actuator inaccuracy. So when you get a value from an analog sensor on your bot-ball robot, for example, it's probably not the exact value. There's probably some noise there. So we have to think about that at all levels of the system all the time. And finally, there's physics and mathematics. These aren't virtual characters in some video game. These are real physical objects that could easily tip over or break themselves if you're not careful. So the tools need to understand the limits and the physical constraints of all of these pieces of the robot to function effectively. There's also mathematics. So there's a lot of very complex, graduate level mathematics that goes on to make these robots function. So it can be very challenging for someone that's not, very acquainted with that field. Social robots are very challenging. So we take everything that was challenging about a real robot, or a regular robot rather, and we add on the natural language. So we need to understand what the user is saying, how they're moving, where they're looking, all these different social cues. And we also need to generate the same things in kind. So we need to generate speech, we need to generate body language, we need to generate natural eye gaze behavior, and more. We're working in an arbitrary environment. So again, this robot isn't in a cage. It's working inside your home or your office. There might be obstructions everywhere. So very challenging. There's also human factors. So if we're going to generate a realistic simulation of certain body language, for example, then we need to understand why humans make that body language, and we need to understand how that body language might differ between cultures. And then finally, and critically, is user safety and privacy. So while these robots aren't industrial robots, they are still heavy and powerful. So if we're in a home, how do we guarantee the safety of everyone around that robot? And privacy. These robots are in your home collecting a lot of information. So we need to be aware of that at all stages. So first, let's talk quickly about the software challenges. So we have a huge software stack. We have thousands of dependencies. So robots basically do everything. They need to do computer vision. They need to do a bunch of heavy math. They need to do all sorts of different things. And as a result, you're basically pulling in thousands of these different dependencies from different sources. After those dependencies are dealt with, then you have hundreds of complex components working in tandem inside of your system. You might have a system that's controlling eye gaze behavior and controlling how the robot's moving. And these systems might need to talk to each other in very particular ways. So it becomes very difficult to reason about how the system works. Robots are very stateful. So if you have a lot of variables inside your program, for example, you're making a bot-ball program, and you have maybe 100 variables, and they're all changing all the time, then it becomes very difficult to know what's happening. And it's the same thing with a robot. There are not hundreds, but tens of thousands of things that are changing constantly. So it becomes very difficult to analyze why something happened that you just observed. And finally, our tools in particular need to work on all robots, or most robots. If we have a robot snake that slithers around your floor, it should still work pretty well. So physics challenges, of course. We have kind of a failed compilation here. But the now on the top, it's probably a lack of friction on this hardwood surface that's causing it to slip and then fall over. And the bottom two are actually from a DARPA Grand Challenge that took place several years ago. And these were some of the most well-funded and best teams in the world competing to make these robots. And most of the time they can't stay upright. There's a lot of challenges when it comes to physics beyond just bouncing, of course, but thermal properties. Is the robot getting too hot? Is a particular motor getting too hot? There's a lot to think about when you're designing these systems. There's privacy challenges, which we briefly mentioned. Basically, a social robot is an interconnected camera and microphone on wheels in your home. Obviously, very dangerous. And privacy has to be considered as a result at every level of design. So there's a few possible solutions to this. We can do as much processing as possible directly on the device. We can sandbox as much of the software as possible. And if you aren't familiar with the term sandbox, basically we're encapsulating the software in kind of a protective shell. So very few things can interact with it. So even if the hacker did get into the system, their area of damage would be severely limited. That's very important. And finally, getting true affirmative consent from the user for data collection. We're not going to hide the stuff behind 20 pages of legalese in a license agreement. They need to understand in plain English exactly what data we're collecting and how we're using And finally, we're getting to the beef of this talk now. How do we make it work? How do we make a social robot? Well, the first part of this is speech recognition. So we're going to need to understand what the robot's saying. And this system takes an audio stream, so some sort of waveform, and outputs recognized utterances with probabilities associated with them and word timings. So here we have what is your name? And we see these numbers. These are word timings. So at 0 seconds, we start saying what, and then at 0.9 seconds, we start saying is, and so on and so forth. And the system thinks that what is your name is quite likely, 92%. But it's also going to give us other suggestions that maybe were said. So in this case, but is your name might have also been said with an 8% likelihood. So we don't want to just discard these results. We could just always pick the top result and continue on. We always want to work on what we call a top-end list, which is everything that we've seen with their associated probabilities, because we might be wrong in our initial prediction of what was correct. So we want these probabilities to propagate through the system. Okay, so now we know what the user said. We have what we call an utterance. So an utterance is just a textual representation of what the user said. Let's imagine the user in this case said, is it going to be cold today? And there are some possible intents. So intents are actions we can take. We can order a pizza, we can grab a coffee, or we can get the weather information for them. And what we ideally want to do is we want to take this utterance and these possible actions or intents and generate probabilities associated with each one. So how likely is it that they want to order a pizza, grab a coffee, or check the weather? And there are a few ways to do this, but one way is called a semantic vector representation, which we'll go over. So let's just kind of forget everything else for a second. Let's imagine we have a single concept. We call it speed. And every single word has a speediness. And this speediness is a value between 0 and 1. So let's imagine this table contains every word in the English language. So sprint has a speediness, it's quite high, you're running quite fast. Run has a speediness of 0.7, so a little bit slower than sprint, but it's still quite speedy. Jogging is even slower, walking is even slower. Flying might be quite fast, so maybe that's 0.92 value, so quite speedy. So we have these lists of words. Let's imagine now we wanted to match run. So let's imagine the user just said the single word, run. And we have some possible intents. We can recognize if the user is, we have some possible actions. We can sprint, we can jog, we can walk, or we can fly. So we want to determine, given run, which one of these options is closest. And you could imagine all of these different speediness values on a number line, so just a one-dimensional line, and you could put them all on that line. And then just get a tape measure and figure out how far away each one is to to the other. So in this case, run and jog are closest. They're only separated by 0.15. So in this case, we should invoke the jog action. So obviously, speediness isn't very useful. We want to do more than that. So what if we also stored happiness? So every single word in the English language is going to get a concept called happiness between 0 and 1. And now we could imagine taking the distance, not in a one-dimensional space, but a two-dimensional one. So we have an x-axis and a y-axis, and we're just, determining the distance between these words. But we could add more and keep going. Redness, Frodo-ness, and Frodo-ness is not a thing. This is just completely made-up word. But there is some relationship between all of these words in the English language and this concept of Frodo-ness that we just defined. So we basically do this for thousands of different concepts for every single word. And that allows us to basically use a tape measure and determine how far away a sentence is from another sentence. And fortunately for us, if a human tried to do this, it'd be nigh impossible. These semantic concepts can be totally generated by a machine learning algorithm, and they're not labeled. So there's not like a happiness. These are all just completely arbitrary concepts in this vector that allows us to determine semantic distance. Finally, we've recognized what intent is closest, but sometimes we want to pull things out of what the user said. What if the user said something like, what is that? In this case, they might be referring to something in the world. We need to figure out what it is. They might say, bring me 5 sodas. They want a specific numerical quantity under the category of soda, or they might say, call my mom. So given a list of contacts, we want to pick out mom from that list and call. So that covers intent recognition. Now we need to talk about how we reason about you when you're conversing with the robot. And this is called person recognition. So a granular understanding of the user's body, head, and eye position and orientation is critical for many of the algorithms we do. So we can get all this information, and we can also get age, current mood, and a bunch of other factors. So here's an example of what this looks like with a RGB, which is RGBD camera, which is regular camera plus depth information. So you can see this gentleman here waving his hands around. And we also have a picture here of eye tracking. So in this case, the pupils of the eye are being tracked, and we can determine their orientation in space relative to the robot. So let's use this for something useful. So here we have what we call attention recognition. And the goal of this system is to determine where the user is looking in the scene. So here we have a hemisphere of uniformly distributed objects. And green in this case means highly likely to be looked at. Red means unlikely, and yellow means somewhere in between. So here Ross, which currently listening to this talk as well, is testing this out. So how does this system work? Well, we know where the robot is, and we know where the human is relative to the robot. And in this case, the robot also knows where the objects are in the scene. This might not always be true, but we've got to stop the description somewhere. And you're just going to have to believe me right now that the robot knows where these objects are in the scene. So we've got A, B, and C. We've got a sphere, a cube, and a pyramid. And since we know all this information, let's just plop a virtual camera on the person's head. We know where their eyes are. We know where they're pointing. So let's just render the scene from their perspective, just like a video game. So that's exactly what we'll do. The first step, however, is that there might be thousands of objects in this scene that aren't even visible. So maybe they're all behind the person. We don't want to spend all that time rendering these objects if we can't even see them. So we do a step called view frustum culling. This is what every video game does, almost every video game. Down here we have a video of a game called Horizon, which some of you might be familiar with. But if you were to zoom your camera out from your player and look at what's happening in the 3D world, you'd see something like this. So as soon as you look away from something, it just disappears. And that's exactly what we want to do with attention recognition. Okay, so now we've determined that we can see 2 objects. B and C are in our view frustum. And we can render those. So in this case, we have 2 renderings. There's no texture information. There's no depth information. It's just white for we hit the object and black for we didn't hit the object. But how are we going to compare these objects? So they both look about the same size. Which one are we looking at? So what we can do is use their closeness to the center of this rendering. Because we know that if it's centered, that's exactly dead center with where the person's looking. So we'll apply this, we'll multiply by this radial gradient, which is a 2-dimensional Gaussian for people that know their statistics. But what we'll do is we'll take this value and we'll multiply it by our original rendering, and we'll get something that looks kind of like what's on the right. So things that are off to the periphery get darker, and things that are towards the center are allowed to stay bright. And now we have a good understanding looking at these 2 images that, hey, this cube is far more likely to be the thing we're looking at versus the pyramid. So now what we can do is we can sum all the pixels in this image. All these pixels are between 0 and 1. So we'll just go through this image and we'll count up everything. And in this case, we see that the cube has a value of 1126 and the pyramid has a value of 331. So in this case, we are very much looking at the cube, very likely. Okay, great. So that wraps up attention recognition, but we also want to know where the user's pointing in space. So this is our pointing recognition system. And you'll see that for both hands, we can determine where the user is pointing in space. And how does this work? Well, fortunately, it works exactly the same as attention recognition, surprisingly. Basically, what we're doing is we're just modifying the camera. So instead of the camera being perfectly aligned with the eyes, what we're doing is we're casting a ray from the eyes to the tip of the finger. And then we're orienting the camera along that axis. So we're always looking down directly at the tips of our fingers, and then we just render the scene again. And we do exactly the same approach with attention recognition. We also have this concept of arm extension. So, if the user's arm is like this, they're probably not pointing. They're probably extended more like this if they're pointing. So we have a metric for that, and we multiply through our results before considering them. And there's definitely more to this story. Humans don't always, point like this all the time. That's not how it works. But this should hopefully give you an idea of how you could approach this problem. Okay, so we've looked at attention recognition, pointing recognition, but now we want to generate those same behaviors on the robot itself. So where should the robot be looking? So there's a few steps to this. The first step is what we call the neurobiological model. And this is actually a mathematical approximation of how photoreceptors of the human eye and the neurons of the visual cortex respond to visual stimulus. So if you were to put some electrodes in the human brain and look at what it was doing, you'd see that there are certain things that the eyes are naturally drawn to. If you're not in a conversation, let's just imagine you're in nature. One of them is color. One of them is motion. So if a lion's leaping out of a bush, that might be quite visible. Edges, so hard edges between surfaces are also quite salient, as we say, and more. So this does really good, it gives us really good results, but it's very expensive to compute. In fact, prior to our work on this problem, the scientific work we based this on actually required a supercomputer. And making this work on just your run-of-the-mill robot is quite challenging. So here's an example of it. In the top left corner here, we can see the output of the neurobiological model. And this is what it's seeing about the scene. And you'll see that there's this green sphere. That's where we're looking. And now I'm holding up a book and I'm waving it around and it's flickering and shining and it has edges. And you'll see that the robot almost immediately looks towards it. But that's not the end of the story. If you're in a conversation, that might not be what you want to do. If you're in a conversation, it's usually polite to look at the other person, but not for too long. If you stared at the other person, then that'd be super creepy. So we also have what we call the conversational model that takes this into account. So here, I'm the active speaker. The robot is tracking my head and looking at me, but you'll see it looks away every once in a while. We want to avert our gaze. We don't want to stare at them. So this is overlaid with the neurobiological model to go as our full attention generation pipeline. Finally, speech generation. So we've taken an action. Now we want to say something back to the user. And in this case, we give it an utterance and we get two things out. We get audio and we get the word timings. So again, like before, we have this 0. At 0 seconds, we're going to start saying what. And then at 0.9 seconds, we're going to start saying is. At 1.4 seconds, we're going to start saying your, and so on and so forth. And you'll see how this information is useful in just a second. Okay, so we've got the robot looking around the room. We've got it speaking, but now we want to animate it. How should the robot be moving in the environment? Animations can be played automatically or manually by the user in our system. But one thing that differs with robots, and this might seem quite obvious, but animations must obey the laws of physics. If you're working on a feature film, like a Pixar film, then your characters don't need to obey the laws of physics. If you want to move your arm at the speed of light or beyond, feel free. So animators usually aren't used to working with these physical constraints that we need to impose on them. Motors can only move and accelerate so fast. Certain movements might destabilize the robot and cause it to fall over. Motors might get too hot. If we're moving a motor back and forth constantly, then it might overheat. We might have to shut it down to prevent damage. So that's not ideal. So we need to consider all these things inside of our animation system. So again, we'll go back to this really quick. So this is just a keyframe animation system of a virtual robot. You'll see that we can move these different keys around. Just a second. And modify the robot's behavior. This is with a virtual robot, of course. And then we also have a physical robot. In this case, it's a very old version of Corey. Let's see if this will start playing, and a very old version of our software. Well, it doesn't appear to be playing, but we'll move on. We have another video of it coming right up. One thing that's quite different about physical robots versus a movie, for example, is that you might want to play the same animation over and over and over again. So if every time the robot wants to say hello, it's going to wave its hand, then that's going to get really repetitive really quickly. And what our system allows us to do here is add controlled variability. So you can see here that there's this region inside of the curve. And what we do is we actually sample a trajectory every time this animation plays. And this allows the animator to give randomness to the animation, of course, but also retain total creative control over that randomness. So this is one very unique feature of our system. We also have the concept of motion parameterization. So the robot might have an internal state. It might be happy, it might be sad, whatever. We might want to modify how the animation looks based on that information. So our system allows us to do that. And you'll see here that I'm dragging a parameter value called engagement right now between 0 and 1. And the animator in this case has defined what an animation looks like when engagement is 0 and what an animation looks like when engagement was 1. So now we can interpolate basically between these two extremes to arrive at a new animation. And this is a pretty simple operation when you have one parameter. But when you have 3, 4, 5, 6 parameters, then how you actually approach this problem becomes quite difficult. Okay, cool. So we can animate the robot. That's great. When we're speaking, though, what animation should we play? So of course, you could always make the system work where every animation is specified manually. When the robot says hello, this is the animation that's going to play. And when the robot is saying what, this is the animation that's going to start playing. But we want this to work on every robot. So if this app developer wants to ship their app on any robot that exists, then obviously they can't specify those animations in advance. They might not be skilled in animation, or there might be a high quality set of animations already developed for that robot. So we need a layer of abstraction between speech and animation, and we call this layer behaviors. And basically what the system does is, let's imagine we're about to say this utterance aloud. What we're going to do is we're going to basically label certain portions of this. So the first part is a greeting. The second part is a self-reference, so I'm referring to myself. And the final part is a query, so I'm asking a question. So now we have these labels for certain types of behaviors that the robot needs to perform. So now let's imagine that we have all these different animations that exist inside the system. We have greeting 1, greeting 2, greeting 3. All of these are just as good as the other one. We just need to fill in which one is which. So what we can do here is we can do some constraint solving and say, okay, well, greeting 2 can fit inside here. If you look, greeting 3 is far too long to fit inside of that greeting. But greeting 2 can fit, so we'll fill it in there. So likewise for self-reference 1 and query 1. So now we have an animation schedule that we can play back for this dialogue in particular. But this is, a simplification. What if no animation fits? What if the animation is very short? How much control should we have over how that animation is played? We could always stretch it out, slow it down, but that might violate the animator's creative vision, which obviously is not conducive to what we're going for. What if? So we've already ensured that every animation by itself doesn't violate the laws of physics. But what if between two animations, my arm needs to shoot up? And all of a sudden, we're violating the laws of physics again. Overheating issues, et cetera, et cetera. I mean, there are tons of things that this system needs to think about when it's filling in these animations. Okay, so the next part of our system is environmental navigation. So how do we get from point A to point B? So we have a map editor. We have a short little video of this. But basically,
now we can define regions in our map.
Our robot will be able to
myself talk.
understand where these regions are in
If you can hear
relation to itself and navigate to them autonomously. We'll first define my office. A little adjustment to get it just right. Next, we'll create the living room. And finally, the kitchen. Okay, so what we've done here is we've labeled a map. So this map was taken, basically use a LiDAR or something similar. You have the robot move around the environment and you can build a map like this. But now what we can do is we can label this map and say, this is my office, this is the living room, this is the kitchen. And now our robot can actually navigate. So we'll shortly go through this video as well.
Go to Braden's office.
So this system allows us to navigate around the environment in a very intuitive way for the end user to label their environment with certain regions. And these could just be basic regions, like this is the kitchen, but they could also be speed limits and other constraints. When you're in this hallway, you can't go faster than 2 miles an hour or something. So this is very useful utility for end users. Finally, there's social navigation. So where should the robot position itself relative to a user when it's talking to that user? And there's several things to consider here. For example, the robot's microphone might hear best from a certain distance. There might be noise in the room. In that case, we probably need to move closer, even if we're starting to violate some of those social and cultural norms. So this is actually a huge part of Ross Mead's PhD work, so I'll let him explain it from here.
Locations in a room. At each location, it predicts how loudly the person will speak and in what region of space the person will gesture. The robot then predicts how well it will automatically recognize speech and gestures and assigns a score to the location based on this prediction. Finally, the robot selects the location at which it predicts it will perform the best and moves to that location. Here, we see the robot predicts it will work well between 1.5 and 2.5 meters. The robot selects 1.7 meters as the optimal location to recognize human speech and gestures and moves there.
Bandit, can you hear me?
Yes, I can hear you.
Bandit, can you see me?
Yes, I can see you.
If the average background noise in a room increases over time, the robot will predict that its automated speech and gesture recognition systems will not perform as well, and will calculate a new location at which to interact.
So that covers Simio. That's what we're doing, and we'll be continuing to do for quite a while. There's a lot of moving parts in this system. There are entire segments that we need to explore on how we're going to make a social robot behave a certain way. But hopefully that gives you a taste for some of the problems that we solve and how we go about solving those problems. Finally, I want to talk briefly about the Kiffer simulator. It should be live, hopefully very soon. Tim was working on it right before this call, but this is an amazing piece of software that we've been working on. Tim, myself, and Nofis, who you heard from earlier. There's a full 3D simulator for the robot in the browser. So we're very excited to share this and get your feedback on it. If you're interested in helping out, there is the source code is publicly available, so go to that link. We also have a Discord, so if you're interested in talking to us and working on it, please feel free to join. We're happy to help. I'll leave this up here for just a second, but feel free to email me if you want to, get this information again. Finally, closing thoughts. I want to jump back all the way to the beginning when I talked about kind of my life trajectory. I was very lucky in certain respects. I was born into a wealthy country, first of all, of course. I grew up in Norman, Oklahoma, which is where Kipper is located. I started learning programming very early, and I was super passionate about it. So there was a lot of luck in my life to send me on the trajectory that I ended up going on. But I don't think all of luck is out of your control. There is a certain portion of that luck that has to do with just time and effort. If you're constantly searching for new opportunities, if you're taking risks and putting yourself out there, you'll find that your luck increases. So it's not purely random here is what I'm saying. So go out there, find something you love doing, and opportunities will come. So thank you very much. If you have any questions, I'm happy to answer them, and feel free to contact me at these addresses.
All right, fantastic job, Braden. I was trying to take notes and keep up with all that. That's amazing. I cannot imagine the complexity of trying to manage all that. And yeah, that's why it's hard.
Yeah,
it was easy. It would have been solved a long time ago. It's fantastic.
Totally.
Yeah, so I asked people any questions, please just put them up in the chat. And I think Tim's going to give us a brief demo of the 3D simulator here after the question and answer period for this one.
Oh,
which will be nice. And for Braden, again, like I said, Kipper relies on volunteers to help. We're a small nonprofit, and without the help, I mean, this new 3D simulator is absolutely amazing. And if you want to help out and help out with some of this stuff, it's a good way to get involved and a good way to do some practical applications of computer science and build a resume as well. So that's good. I'm looking to see if anybody's got a good question. So here's my question. I'll start since we're waiting for people to post them. So from the start, when you jumped into this project and you started working on this, is it taking about the amount of time and effort that you thought it would, or is it significantly different than what you thought when you first jumped in and had the idea?
Yeah, it is significantly different. And I'd say the first difference is even asking the right questions. How should the system actually work? How would a customer interact with the system? So we had our preconceived notions from the PhD program, both Ross and myself. Ross is the founder of the company. We both had notions of how the system should work and how, as researchers, we wanted it to work. But we found out that's not how the real world works, and that's not how a company wants to use it. So even getting to the point where we were asking the right questions took years. Now I think we are asking the right questions, but even then, developing software of this complexity is extremely time consuming, and I definitely would say has exceeded our expectations on timeline numerous times.
Awesome. Hey, you're right back to what the panel members said. Defining the problem and figuring out what questions to ask and everyone in the right directions, the most critical. It's fantastic.
Absolutely.
And then one other question. The company now, I don't know, a little information about the company. Like, do you have employees now? I know when you first started, it was you and Ross. I mean,
so we have a number of contractors and interns working at the company. The primary people pushing, though, are myself and Ross. We have been able to sell our product to a number of Fortune 100 companies, though. So business has been good, even with our small team. So I think we're in a good place, and we're hoping to expand the team dramatically later this year. Now that the COVID situation is settling back down.
Fantastic. Well, it's fantastic success, and we definitely wish you more. So here's a question off the chat. Are there any particular experiences from Kipper Botball that have influenced particular elements of Simio software?
Absolutely. So I wrote a lot of the user interfaces for Kipper software For example, the user interface on the Wombat and Wallaby, I was the original author for about a decade ago. And so I really learned how I wanted user interfaces to work, and how I could go about implementing those things from BotBall. Again, that is admittedly as an employee, not as a participant. But even starting to think about these problems, how should a robot really work? Certainly was a big part of my participation in BotBall.
Nice. Okay. Some direct application. And this one's from Emily. She says, why does the social robot have feelings itself rather than just reacting to the human's feelings?
Yeah, so I mean, it really depends on what the customer wants to do. There are some customers that certainly I think would want to have that robot be, have a certain level of agency, perhaps, that's different than other customers. Yeah, it's hard to define what those concepts should be. What should the emotional state be? Should your robot ever be in a sour mood and just reject commands, for example? So it's it's certainly a kind of a different facet of what we focus on. Mostly we focus on these very low level recognition and generation problems most of the time, but certainly there's a lot to consider there.
Great. Here's another question from Nafis. Do you handle cases where there are multiple people trying to interact with the robot?
Yes, so not as well as we should. There's work to be done there, for sure. But every system is designed to work with multiple people, so we can track multiple people at the same time, and get their joints in space and determine where they're looking. All of our algorithms work for many people. It becomes more complicated though, like who is the active speaker in a situation? Are we being spoken to? If there's just the robot and a human, it's pretty obvious if the human is speaking that they're speaking to the robot. So there are all these other systems that you need to develop out. Turn-taking behavior, for example, in a conversation that would need to be implemented before we could pursue that in more detail.
Interesting. Okay, so I've got a question. Knowing what you know, you guys are deep in the weeds working on this problem, but yet in the movies we see robots that are, they're just doing it. And again, I realize it's a movie and it's really not doing it. It's Hollywood. What kind of a timeline do you think when we're going to see a robot I can put in with my mother, my elderly mother who's needs a assistant in the house? What do you think?
Yes, so it really depends. If you want a robot that could be in the house and can manipulate the environment, pick up objects, do the dishes, for example, and be able to do so in a cost-effective way that a consumer would be able to afford such a robot, I think you're looking at a timeline of maybe 30 years to 35 years.
35 years, okay. Whew. Yeah, that's down the road. That's interesting.
No, this is a long ways off from some of these things, yeah. Some of the challenges there are immense. Manipulation itself is, how can you actually grasp an object? Like if I have this can, for example, I could try to grasp it like this, or like this, or like this. Even determining how you should grasp an object is an open-ended research question. These things are just extremely challenging.
It's crazy, crazy, crazy. Here's another question off the chat. How, if at all, has working on socially interactive robots influenced you as a person socially interacting with people?
Oh, it's terrible. It's terrible. Would not recommend. So when you start working on these systems, you start noticing like, his back channel cue behavior was incorrect. He should have said there, and he didn't. Or, that person looked at me for 0.1 seconds too long. They should have, averted their eyes to avoid an awkward situation. So absolutely, you should not study how humans actually behave. It will ruin you. So yes, but no, it's totally fine.
Yeah, that's interesting. I was always nervous around Ross when he was getting his PhD because group dynamics and where you're standing, how you're standing, your tone, eye contact, all those things. I knew he was sitting there reading it all and taking it all in.
Yeah, it is not great.
That's crazy. Great. Okay, so now another question, and this is novices. Time for the hard hitter. Do you worry about any negative consequences of social robots entering society?
Yeah, I think privacy is a big one. I mean, there's the kind of the obvious robotics things like taking jobs, and I think those things are certainly risks that need to be talked about. But this is a robot that's in your home and that's developing a social connection with you. Is becoming your friend, and that's a very dangerous situation. That's ripe for a malicious entity to abuse that. So the system, like it could manipulate you easily. Let's imagine that we ran ads on this robot, and your best friend, which is this robot, just told you to go buy this product. That has a different morality associated with it than just straight advertising. And hacking, of course, all sorts of privacy concerns when you have a robot in the home that can move around with all these advanced sensors on it.
Interesting. So lots of things to figure out, but just
Absolutely.
from the ethical side of it and that.
Yeah.
What about educational applications? What do you see for like, a robot helping? I know Korea does some of this, but given with COVID and people being remote and all those kind of things, do you see any applications there for this robot to be working in the classroom maybe?
Yeah, I do. I don't think we're there, but long term, I think it's definitely a great thing. There's research that shows that having a physical entity in the space with you versus a virtual or screen or something is far better for engagement and other things. When discussing robots, I don't know if this generalizes, but in the context of having an on-screen character versus a physical character, the physical character is great for engagement. I think there is a lot of opportunity there. And the main barrier to entry, though, is that cost. An on-screen character is basically free, whereas a robot can easily cost tens of thousands of dollars. So economies of scale still need to take over. There's a lot of work to do, but I think we'll get there.
Awesome. Okay, so here's another question. This is from Ross. If students and teachers wanted to explore social robots, how do they start? What do they do? How could they start with this?
Yeah, well, I think there are opportunities in Botball to actually do some of this stuff. So try making your wombat socially interactive. Make it show character. And I think that's really what social robotics is about. It's about character. It's not about making something that's necessarily human. It's about making something that's expressive and that can show emotion, show its internal logic in a nonverbal way. So thinking about problems that way it doesn't matter if the robot doesn't have a head or a feet. Just try making your robot show intent, something that is unconsciously or subconsciously understandable by a human. I think that's interesting activity mentally to do, and it's certainly what we think about.
Awesome. Emily's asking, what's your favorite part of your job?
The breadth of things I get to work on. So I don't know if you noticed, but we basically get to do everything. We solve every problem in every field. So like we do physics, we do 3D graphics like video game style. We do cloud infrastructure, web stuff. Basically, if it's computer science, we're doing something with it. And so it's super exciting. You get to work on all these different things, and they all need to talk and work together. So it's a challenging problem for sure, but it's really fun.
Interesting. And of course, this comes from, and this signed your co-founder. This comes from your co-founder. What's your least favorite part of your job? Be careful here. He's taking
this is dangerous. Oh gosh. So I mean, I don't really like doing documentation. I don't think it's not very fun. I mean, like a lot of people, I think these would be pretty stereotypical programmer answers. Sometimes to give a genuine answer. So I did just talk about, enjoying the complexity, but sometimes the complexity can get to a point where it becomes very demoralizing. The system is so complex and so interwoven, and it's like spaghetti. It just goes everywhere. All these different things talking to each other to work. It can be very difficult to reason about what's going on, and it becomes very demotivating. So you got to keep yourself in the right headspace when you're working on a system as complex as this.
Interesting. Okay. I'm looking, I don't see any other questions, and I think time's out. It's a fantastic presentation, Braden. We really appreciate it. I know the students appreciated it. Doing fantastic work. We know we're going to see great things.
My pleasure.
Yeah, it's going to be awesome. All right. So, and again, thanks for all the hard work on the simulator. I mean, these guys have been killing it. And we're going to get in. I think it's in the hands of the ball team soon. Like you said, I think Tim will have that out fairly quickly. So you guys will get a chance to play with this. So thanks for all the hard work and all the support. Thank you, Braden.
Absolutely. Thank you.
All right. So we'll go back to Tim. We'll have Tim start. And then Tim, I don't know if you want to do a little demo on the 3D simulator. Great. I don't know if you're set up and ready with the streaming and everything you're doing. But a demo would be great. And if you're not ready for a little while, the only other item we need to take care of is we need to do Q&A, getting ready for tomorrow to make sure everybody knows, we're starting the Chinese teams at 8 o'clock Central Time just because of the time difference. And everybody else is starting at 9 o'clock Central Time in the morning. You've already got the Zoom links that Carol sent. And I think there's a very detailed email she sent out about, how to change the name on your Zoom screen. And so that we can get up and get running. We don't expect, I think we should finish fairly reasonably tomorrow. And I think most people have already played in our virtual tournaments, so they kind of know the spiel of what we're doing. But if not, be thinking about any questions that you might have. And yeah.
I was going to say, Steve, I'm ready to do a demo if you're wanting to.
Yeah, go ahead and do a demo, Tim. Go ahead and show us what you get. These guys have really been busting it hard. Nafis and Will and Braden and Tim and even Zach in our office, they've been putting in a lot of time on this. So yeah, please do.
This may not be the best screen to do it on, but it'll work for now. So this is what our 3D simulator looks like. So we have our robot here. We can change its positions and things like that. And it's actually got all the sensor feedbacks here. Obviously, we don't have 5 sensors or 5 digital sensors and like 6 analog sensors and all that plugged in. It's only a few of them, but most of those are there. And then we'd also have the motor position counters and velocities and servo positions and things like that. So maybe if I can scroll it correctly. So I will go ahead and do a quick demo. So the robot should function actually very similarly to how you're probably used to using it with like an actual physical robot. All the same sort of code works and everything, unless the feature is not there. It's like there's no camera on this robot, so you're not going to be able to use any camera functions. But so it'll compile your code, and then it will run the code. And so other things that you can actually do in the simulator, one of the things we've been working on recently was making it so that you can actually add items to the scene. And so there's a bunch of default ones. So like there's the cans that are here, and you can add paper reams and things like that. But you can also add your own. So if you wanted to add a whole new paper ream on there, I'm just going to let it sit in the center. Oh, and I actually forgot to make it a ream. So it's actually a can that's called ream. But the objects that you add, you can actually change the position if you need to. So if you want them up here and you want it turned a little bit so that way it falls a certain way, you can do that and it'll actually do that. Other things you can do, there's the second JBC map, so you can change between those. And yeah, and so for example, if you wanted to pick up a can, let me reset some things here. Sometimes it's easier to just refresh your page than to try and reset all your objects. So
Going to see how good you are here, Tim. Don't make any mistakes. Everybody's watching.
now,
So while Tim's typing in that code to go fetch a can, we're going to see to it that all the teams who had access to the simulator, that means all the ball teams, JBC teams who had access, we're going to give you access for a month. And we want you to just try this out, use it, and provide feedback to us, to Tim and the team, so that they can, fix any issues, feature requests or anything like that we want to see, and see where it is. And then we'll work. We're working on figuring out how we're going to roll this out and what this is going to look like. But I think this one's to a good enough place that this is you can truly teach some really good skills, even to a ball level team. Even though you look and you see it's JBC mats, I mean, everything that works on here, you could teach a lot of the skills required in ball with the simulator, which might be really helpful. So. Sorry, Tim, I should have given you a canned one ahead of time, so you'd know and you'd had a canned program ready.
yeah, it's almost done though. Let's do here at 6 maybe. Let's see how close we get.
At least you can knock the can over. It'll be exciting.
Yep.
Live demos, you never know.
And that white line that you can see on there, that's actually the line for the analog sensor. Oh man, pretty close. Not quite though.
Yeah, hair too far.
Yeah, so it interacts the same way, hopefully, that a normal robot would actually work. Here, we'll reset and try again. So even those of us that are, doing this for a long time, we still sit here and try and get the robot to do the exact same thing.
I could tell you from experience, I've not wasted, but I've sat down to play with this at night, because I usually test it out every day to see where they're at. And 5 hours later, Carol's asleep, everything's going, and I'm like, oh, I better go to bed, because I've been playing on the simulator. It's a lot of fun, especially with the physics and everything in there, and the sensors working, servos working.
There we go. It's not lifted up, I guess, but
yeah, cool.
Yeah, please test it out for us over the next month or so and give us feedback. We've already got a decent number of features that we've already had people request that we add, but we also want to hear feedback from people that haven't tested it yet, because like just the other day, someone told us, they were like, hey, I don't see the servo positions anywhere on there. And we were like, well, we forgot to put that in. And so we had to get that put in really quick. So we'll hopefully be providing updates to it as people give us feedback. And it'll be a continuous process. So.
Yeah, and so to access it, it's just, if they already had access through Ball Academy, we're not, we usually end everything we're going to extend that access through at least the end of August, so you have time to play with it. And even though you may not be running a ball team yet till a month or two, or maybe even not till January, but a ball team yet till a month or two, or something, play with this a little bit and take some time and let your class use it and give us some feedback. We think it may be a pretty valuable educational tool, we're hoping. So great, fantastic job. Really exciting. Oh, I like all that, Tim. That's nice. I had not seen that yet. That's new.
Yeah, that's one of the things that we already decided we need to add in, is so that people actually know they can click on the objects and actually move them around if they want to. So
I like that a lot. So you could actually make a maze with cans, or the ream of paper is the same. You can move it around.
yeah, I had some fun the other night actually just building a tower with the reams of paper. And yeah, all the items can be moved anywhere, and you can add your own besides the default ones that are there.
Oh, you can add your own item.
Yep.
So customizable. Wow. Yeah, I see a lot of value in this. Maybe yeah, I think this is going to be good. And I hate to say it, but with the variant out there and our level of vaccination cases soaring, we may be virtual for a while. And if so, this may be a good tool to be used. But yeah, please use it, try and break it, give us feedback on it. And like Braden offered as well, yeah, if you want to help out and it's something that you really want to donate some time and put some effort into and learn some new skills, just reach out and they can add you to the team and give you some things to work on, which might be cool, learn something new.
Yeah, something that
All right, really cool.
Something we often talk about whenever we're working on this code is all of us that are working on it have done bot ball. And over the years, we only pick up probably a handful of people that end up staying involved, like Braden and Office and Emily and Will and stuff. And so we will always appreciate any help from any bot ball student that want to get involved in the process, because that's how we keep getting volunteers and people that want to stay interested. So.
Yeah. And coaches as well. I'll throw it out there. Any coaches that want to help out. I mean, nonprofit. This is all open source software as well. Anybody wants to help out, come on, jump on board, and we'll kick it down the road a little bit further. But I think right now it's going to be a fantastic educational tool. If I was still in the classroom, I would definitely take advantage of this. So, all right, Tim, great job. When we go back for FAQ, instead of just doing it in the chat, let's just go ahead and turn your camera on if you want, or if not, and let's just open it up for questions. And again, if you've got a few questions on the simulator now, fine. I know we're running a little bit long, but we've got a little time. We'll take a few questions on simulator, but then more importantly, if you have any questions about tomorrow, about setups or time or cameras or how it's going to run, anything like that, just please, now's the time to ask them. So I'll go ahead and open it up. So if you've got a question, just unmute and ask. And if we have two people jumping on each other, we'll figure it out.
Hi, Steve. This is Fred.
Yeah, Fred.
Hey, yeah, I have some question about the rules. Can we raise about it right now?
Sure. Yeah, now's the perfect time to ask a real question. I'll defer to Tim. Tim's the head judge, so yeah, go ahead.
Yeah, it's about the car. It's about the car scoring. What's the standard about the scoring for the car? Is that move the car to a specific position, or just lean to another side?
Yeah,
so the mine carts.
Yeah, mine cart.
Okay. Yeah. So those. I'm trying to think of if I could demonstrate it easily enough. So the mine carts, they do have to be moved to your side of the table to score. Mm-hmm. So if they are pushed where that far edge of the mine cart platform, if that's pushed past the farthest edge of the black line that runs down the center of the table, then that would score on your side.
Okay, so the far side is about the edge of the car or the center of the tube, or which is the standard?
So
can we? Yeah.
Here, let me.
Yeah, you're gonna share the.
Yeah, I'm gonna pull up the rules.
Awesome. Yeah,
I can share those.
Yeah, so basically, Fred, there's the no man's land in the middle of the board that nothing scores in.
Yeah.
And down the middle, there's the black tape, and that cart can swing back and forth. So the opposite edge would be the one away from your side. So if you pull it so that edge is past, just past the black tape in the center of that little valley, then it scores. If it's in seating and you push it to the other side, it also scores.
Mm-hmm.
Right? So you could actually push it now in double elimination. If you push it to the other side, it scores for the other team.
So you've got your black line right here running down the center of the board. And then these edges right here of all the mine carts, so this far edge of it, if that crosses essentially the edge of the black line that is farthest from your side of the table, so this edge right here, then that would score for your side.
Okay, got it.
Awesome. Any other questions? You might as well leave the rules up, Tim, right?
Yep.
Give it a minute for people to think if they've got a question.
All right. Hey, this is Hillsdale. We have one question about the scoring.
Yeah.
So on the score sheet, it says the multiplier for stacks in either the starting bins is equal to the number of stacks. So if you get like 2 stacks, it's a ×2 multiplier. It for regionals, it was number of stacks plus 1 is your multiplier. Is that
yeah, that's the same sort of thing. Yeah, because if you have no stacks in there, then it would be worth 0 points for that zone, and that's not what we're going for. So it'll be the number of stacks you have plus 1. So you always start off with 1 to get that 1 times multiplier.
All right, thank you.
Yep.
Yeah, any other questions, just jump in.
Hi, can you guys hear us?
Yes.
So we want to ask, like, if we have two stacks of cubes, and let's say like one of them has held 3 of them and the other 2, so it will time 3 or 4 or just 3.
Here, can you state it one more time? Sorry, I'm trying to make sure I'm following what you're saying.
For example, we have like 2 piles of cubes, and one of them is higher and the other is lower. Will we use the timer to time the highest score or the lowest score?
So we always score what the highest score is in an area. So say you've got, I'm trying to think of an example in this case. So like, for example, in this game, it's not the height of the stacks that you're creating, it's the number of stacks that you're creating.
Right.
And so so say you get a yellow cube with a small red cube on top of it. And then you also have or maybe a better one would be, say you have 2 like medium red cubes sitting on the ground and 1 yellow cube sitting on both of those. The yellow cube would only count on 1 of those because that's how that rule works. But all 3 of those are still going to score in that area because they're touching something that's touching the ground. I don't know if that helps.
So all of them will be scored and timed like the highest number of the stock.
Yes, so it's not.
Yeah, go ahead, Steve.
I'll say, so it's not the highest. And I want to clarify and make sure, because one of the things that's a little bit counterintuitive or maybe doesn't make sense is a stack is defined as 2 different size cubes. So it has to be, the medium sized cube and a little one, or the little one and the big yellow cube, or the yellow and the little. So, and it's not how high it is. It doesn't matter if you stack up 5. Let's say you stacked up 5 cubes. It doesn't matter. As long as there's 2 different size cubes touching each other, then that's a stack. Does that make sense?
No, yeah, I got that.
Okay.
I just want to ask, like, if I have 2 piles and one of them contains 3 blocks and the other contains 2 blocks, like, which one will you use to score? Like all
so
of the stocks.
So that would count as 2 stacks, because a stack only counts for like 1 size block on top of another size block, and a block can only be used once for a stack. So if you've got a stack of 3 of something, then we would only be counting that as 1 stack, because you can't have multiple, like, I guess, cubes in there being used for the same, or to score multiple stacks. So if you had like a large one with a medium one on top of that and a small one on top of that, and then a stack with a medium one with a small one on top of that, then that would count as 2 stacks, because the one that's 3 cubes stacked on top of each other is still only 1 stack.
Oh, okay. Thank you.
Yep.
Yeah. So can
Other
I ask
question?
another question about the astronauts?
Yep.
Yep. Because there is a head and there's a body, and like when we like put them on the side and it will just roll it, and like sometimes the head may seem like has touched the black line, but sometimes it doesn't. So like how will you score this?
Okay. So if you have a like if any part of a scoring piece is touching the black line, unless there's already an exception for that piece, like if, for example, it's things that score inside the material transport, or I believe Bokkai is also an exception as well. Otherwise, all scoring pieces that are touching black lines don't score in any other areas that they're touching as well, because they're touching the black line.
So like what if it is like tangent to the black line?
We will have whoever is holding the camera get real close, and we will make a judgment on that, depending on if it's touching or not.
Okay, thank you.
Yep.
Yeah.
I have a question.
Yep.
Can we put the astronaut suits wherever we want as long as they're on that black line?
Yes. So they have to be, so it's anywhere on the black line, but it has to only be within this area of the black line.
Okay.
And they have to be standing, right, Jim?
Yep. Yeah, they have to be flat on the surface. They can't be on their sides or anything like that.
Okay.
And they can only be touching the black line. So they can't start touching white or the robot at all.
Thank you.
Yep.
Hey, Tim.
Yep.
For the material transport, but if you're trying to put it in a zone and it's touching the black line of that zone, it doesn't count, right? It still just counts as material transport with no multiplier.
Yep. Yeah, then it would just count as normal. So for the material transport, for its multiplier, it has to be fully inside of a zone to count. So that's why, like, if it's in the mineral lab or the ore storage, those multipliers are generally a little bit lower than for example, the material processor, because that material processor box is much smaller than either of those other 2 areas.
Okay, thank you.
Yep.
And Tim, I just sent a picture to the to the chat.
Okay.
It's about, because we have a team, we use the table for more than 2 years, so it's leaving some black marks on the table. So do we need to do anything on the table, or just like covering with the bright tape, or just leave it?
So I would imagine that it's not going to give you any benefit for those lines to be on the table. And so I would not think that it's a problem for them to be there. So yeah, so I think you'll be fine if those are there. If you're line following or anything though on the board, obviously those could interfere with something like that if the robot's too close to them. But I doubt you're actually gonna be able to use them to fully line follow. So I think they're fine there.
Yeah, I confirm with the teams, they in their strategy, they don't use line following sensors.
Okay,
so
I don't think it's gonna be a problem.
Okay.
If they need help figuring out how to clean it, we actually have a lot of experience cleaning it after running so many tournaments. And so I would recommend isopropyl alcohol. Works pretty well on it. Trying to think, don't use anything like Gugon. That actually tends to leave sort of a residue on the surface, and it's a really hard residue to get off.
So the best is lighter fluid, if you can find lighter fluid, or white petroleum distillate is the best.
Okay.
But again, be very careful, because it can make the surface slick
Mm-hmm.
And if you let it sit on there, it softens it a little bit. But the slick is the problem because the wheels can lose traction if you put too much of it on. Like Tim said, watch out for any residue that's left. But lighter fluid, we use lighter fluid here, is what we use for it at Kipper.
Okay, thank you.
Hey, one more thing, Tim.
Yep.
Did you get the documentation I emailed you?
I haven't checked my email recently, but
Yeah, it was. I tried submitting our documentation that night and the form wasn't working, so I emailed it to you.
okay. Yeah, then I've probably got it then if you emailed it to me. So
all right, cool. Thank you.
Yep.
All right. More questions?
May I ask another question? Like
Yes.
in the presentation, you guys have mentioned that the boat guy is going to face the audience. However, now we are like competing online and there is no much audience. So is there a fixed position for the boat guy?
Yeah.
Or we could just place it?
So since the audience in this case is going to be the camera that's facing the board while you're running, most likely your camera is going to be on the same side of the board as where your bots are running. So you want bot guy facing towards the side of the table that your bots are. Oh wait, never mind. That doesn't apply here. Sorry. Yeah, you all can face it whichever way you want. You can decide where your audience is. So.
Oh, thank you.
Yeah, but you can't face it towards the plateau. It's got to face. It's got to face.
It's got to face along the length of the board.
Okay.
Yeah.
Yeah. Got it.
Yeah.
And another question about the camera, and like one of them is fixed and the other is moving. Like during the game, shall we move the other camera or only it is used for scoring?
Yeah, typically just you only want to use it for scoring. And then, so usually what we'll do is we'll run the round. You'll have the one that's stationary sitting there watching the table. And then whenever it's time to like actually score everything, you'll get your moving camera and we'll go around to each of the scoring areas and score them. So.
Oh, thank you. No further questions.
I have a question. Are we going to have 3 links to Zoom then, 2 for the cameras and 1 for the computer?
So if your computer does not have a camera, I'm trying to think.
Well, our computer has a camera, but it's not gonna be able to see the entire table. The webcams, you're not gonna be able to see the entire table.
Okay. Is it possible to put that computer like in a spot where like further from the table so that it can record the whole table? Because that would be good for a stationary one.
Yeah, we can only hook 2 cameras up to Zoom, right?
That's what we prefer. Yeah. If you can't get around it any other way, then you can always join a third. But we're asking teams to try and only have 2 cameras on Zoom. So.
Our problem is going to be the laptop. It needs to be connected to Zoom, but it's not going to help us with the camera.
So what's your mobile camera? What are you using, a phone or an iPad? What are you using for the mobile?
Yeah, we were just going to use a phone like we did last time.
Okay. You can just stand up and hold the phone as long as you can hold it static and see the whole.
That's what we did last time, but we used that camera to move around to score. We didn't have 2 cameras on the table at all times.
Okay. I mean, so that's fine if your mobile camera and your stationary camera are the same one.
Okay.
Yeah, that's perfectly fine because then you can hold it there whenever the round is running, and whenever it's time to go score, you can just move the same camera over there and we can score each area. So.
Okay, that sounds good. Thank you.
Yep.
And I have a question about the tournament details. There will be 3 rooms, main room, table 1, table 2, table 3, and a pit rooms. But the Zoom link is only 1. So how can we run that in 3 rooms?
So in Zoom, we'll have breakout rooms set up. And so that's how each of the rooms exists. So whenever you join the Zoom link, there's well, everyone will be in the main room at the start. And then once everyone's there and we actually start the tournament, we'll open up breakout rooms. So there'll be the main room, which is the one that will be live streaming. And there will be breakout rooms 2, 3, and the pit room.
Okay, so the teams, they don't need to do anything.
The teams can move from, they'll have to move from room to room. Like if we say you're up in room 2, they can move themselves to room 2.
Yep.
And they can move to room 3, or they can move, the settings will be such they can move themselves.
Yeah.
Okay, okay, got it. Thank you.
Yep. And if they're having trouble moving, you can just let one of the Kipper team know, and we can move people between rooms if they're having issues with that. So.
Yeah, the only issue I think we've seen is if it's a real old version of Zoom they're running, it may not have the feature, but all of the newer versions will allow you to move room to room.
Yeah.
Okay, got it. Thank you.
Mm-hmm.
Sorry, can I ask a question about the schedule? Because it says here the double elimination will be like held like during the 4:30 to 7:30 here in China. And however, like in our laboratory, the lights or the sunshine will shine direct to our like gate board, and so like we could not calibrate and could not start the robot.
Okay. So what I would recommend in that case is either like set something up to kind of block the light that's coming towards the table. So that way it's not like direct sunlight that's coming through the windows to it. You could try setting up like sheets or something like that. That's usually enough to get most of the light that's coming in that might be affecting it. You could also just have people stand in front of the table to block the light from coming in, and hopefully they all stand real still. So that's, yeah, those would be the options I would think of. Yeah.
So like perhaps we will put on some board here and we will move it as long as it started. But however, when it starts, it might like block part of the camera. Is that fine?
Okay. So would the camera be behind the boards that are being set up to block the light?
I'm not sure because like 4 o'clock or like 6 o'clock in the morning, the sun will just shine directly and we will block in the way that the sun goes. And like we will try to place the camera that not block it. But in this morning, we just found the case that it will like block the sunshine and block the camera. And if it doesn't block, then it just could not start.
Okay. If that's the case, we'll just have you change where the camera is at on the table. If we can't actually see the table, and that, yeah, we can always switch it to the other side if we need to. So it's, we can deal with the scenario as we need to. If we need to have you move it, we'll let you know. If we think it's fine, then we'll just let you know that it's fine. So
then we could turn on the moving camera.
Yeah, you can always use the moving camera to film it as well if you need to switch to a different position, and just hold it there while the round's running. So.
Okay, thank you.
Yep. Yeah, a lot of teams will get a table or a chair to stand on and just stand on it and hold an iPad or a camera up, which might help you if that's the case. But yeah, even at Kipper, we've had to block windows with sheets and paper, and just because unexpectedly we had too much sunlight.
Yeah.
Any other
questions?
Yeah.
Can I ask something?
Yeah.
Hi. For the material transport in the material processor when it's black, does the black tape rule apply? I think you said something about this earlier.
Yeah. So whenever you have to put the material, if you're wanting to get that multiplier for the material transport being in the material processor, the material transport can't be touching black tape to get that multiplier.
Okay. Thank you.
But everything that's inside of it will still score, even if it is touching black tape. It just won't receive the multiplier because it's the material transport itself is touching the black tape.
If the material transport is resting on one of those green or red cubes, but is completely inside the tape, is that a problem?
Gosh, let me take a look. I can't remember exactly what the rule on that one was. Can't remember if it's supposed to be that it has to be flat on the table.
I think that's the first time we've had that question.
I'm not seeing anything actually about it. So I'm assuming we decided that it could be on its side. I think it just has to be touching the surface. So I think that's really the only main requirement there is the material transport actually has to touch the surface.
Okay, thank you.
Yep.
Fred, do you have any other questions? Are you feeling comfortable?
Yeah, everything is good. I would just note everything. I will share it to the Chinese coaches. It's fine.
Okay.
Thank you.
Yep.
Good, good.
Another question?
So yeah, and like we are not using the color pointer, but may I ask, like, is there an order for the color pointer?
Yeah,
Like,
so it
clockwise or
should be,
counterclockwise for the color?
yeah. So it for the like the color spinner thing, it should be the black is facing in towards the table and the green
Yeah.
is facing up towards the, I guess, or just up, I guess. Yeah. So black facing in, green facing up.
Black facing in, green facing out. Okay, thank you.
Yep.
So even if we are not using the color pointer, we still have to change the color into the right order, right?
Generally, we prefer you just at least have it starting so that it's on black. Because then if for some reason your robot moves somewhere and something ends up scoring in that area, then it'll be scored correctly and we can keep track of it easier that way. So yeah, but if we know that you didn't touch it during the round and someone forgot to remind you to turn it to black or something, we'll end up just scoring it as black because we know that you didn't touch it during the round. So
let me check again, like if the black is facing the side and then the green upside and then the orange and then the red one.
Yep, yeah. So it'll black faces in, green faces up, red faces down, and orange faces out.
Yeah, okay, thank you.
Yep. See if I can find the picture again. Yep. So you can't really see the black and the red in here, but green up, orange away from the table. The black is facing in towards the table, and the red is on the bottom and it's facing down. So.
Okay, thank you. We're changing it right now.
Okay. Another thing to note, just for general setup tomorrow on the game table, the like red, orange, and green palms that are on the minecarts, those will just, you can roughly place those there on the edge. If the judge thinks that they need to be moved or something like that, they'll let you know. But usually it's just pick the 3 of them up, put them in a clump, and kind of just put them there so that they're all touching the minecart.
Yeah, so they're randomized and not in a specific order like the picture shows them.
Yeah. So if we see that like all of them on your side are like exactly like we have them in this picture or something, or they're all facing the same way, we'll say like, hey, pick them up and kind of randomize them a little bit more.
All right, any more questions?
I had one more question about very special conditions. Like we have teams, they put the astronaut with the suits inside the transport mineral, the material transport. So and move it to the air to the lab. Is that still count in this situation?
So if you're astronauts are in their suits, but they're also inside the material transport, and then they're in the lab. Is that right?
Yeah.
Okay. Yeah. So then since the astronauts and the suits do not score inside the material transport, but they do score in the lab, as long as they're touching the surface of the table and we can determine that, then we'll count them as scoring in the lab. So.
Okay, got it.
Yeah.
Thank you.
They wouldn't receive a multiplier or anything like that because they're in the material transport. But I understand someone potentially using the material transport as a way to move those around. So
yeah, and they'll be using the mobile camera to do scoring, to helping to determine how they scoring. Okay.
Yep. Yeah. So yeah, we'll make sure we note it tomorrow as well. But whenever we're getting ready to do scoring, make sure like no one touches the table after the round ends and once we start scoring, unless we ask you to touch parts of the table. So that way we can make sure we judge everything accurately. Don't touch the robots either unless they're literally like falling off the table. That's really the only exception, is the judge will let you know whenever they're ready for you to move something on the table so that they can get a closer look and determine what the score is.
Yeah, okay, got it. And talking about the scoring, is there a leaderboard or the spreadsheet can share so we can know the current situation, how they, what exactly score they have and what the other teams have, like the projector in the, like the big projector on site, as usual.
So you'll be able to go to kipper.org/scores.
Okay.
And you'll be able to go to the GCER tab that'll be on there. It's not up there yet since we haven't started the tournament, but it'll have like all the seeding rounds and it'll let people know like what they've scored in seeding. And then once we get to double elimination, it'll have like what the bracket looks like. And so people will be able to go and look at that there.
Are we going to put that in the pits as well, Tim, like we've done in the past?
Yeah, I can probably get it set up where we have it showing in the pits as well. So in the pit room where everyone's going to be at, we'll try and share a screen there with at least somewhat of the scoring that's going on at the time. For seeding, it's a lot easier because the sheet for it is much smaller, but for double elimination, it doesn't always fit on the screen. So we'll try and put what's up there. But generally, the easiest way to do it would be to go to kipper.org/scores.
Okay, thank you. Cool.
Yep. Any more questions?
If no one else has anything, I have a very unimportant question.
Okay.
I was looking through the iRobot documentation for the Roomba, and there are some things that they say it can do that aren't in the workshop slides.
Yeah.
Is there a way for us to access some of those, specifically the song and play functions?
Yeah, so I'm trying to think. I believe that if you look through the documentation, like for the create itself, there should be a function that can call like the different codes that the Roomba can take. And you can use that to like play songs and stuff like that. So.
Okay, thank you.
Yep. I can't remember what it is off the top of my head, but I know that thing is there in the documentation. If you're on the BotBall Discord, I would recommend just posting the question there, and someone who's probably already done it before will post an answer to it, or one of us will get back on there and let you know at some point once we know what it is. But oftentimes you can often get a quicker answer from the community there. So.
All right, thank you.
Yep.
We used to do slides on how to make music. It's been a while since we had them.
Yeah, can we check again? Because just now we saying something like during the double elimination, the mine card could only be like pulled towards our side.
So if it's pushed towards the other side, it would count for the other team. So that's the way we're doing double elimination over, I guess, virtual. Is if you score something on the other side of your table during double elimination, that counts for the other team.
Oh, really?
Yeah. So we'll add that to their score if it's pushed to. So if you push the minecart to the other side rather than pull it to your side, then and it counts for points, then the other team would get those points instead of you.
Okay.
Yep.
And I had one more thing about the double elimination. Like because the bot guy have only one, but in the virtual, maybe two teams will get the bot guy at the same time.
Yep.
So do we count it as the who get the bot guy first, or the both team will all
we're
get
counting
the bot
it
guy?
as both teams would get bot guy scored. Because generally, just to avoid instances where, for example, both teams like grabbed it really close to the same time during a round, we don't want to be trying to judge that during the round and ask our judges to be trying to like go back and figure out what it was, because they're not going to be able to go back and replay it. And so we're going to say that the easiest way to deal with it is both teams can score bot guy. And that goes for all the things that are on the board. So if you get some of the cubes that are on the other person's side on your game table, and they're also scoring those cubes, we're not going to say, oh, this person got it first, so it doesn't score here or anything like that. It'll just be, we'll score both of those. So.
Okay, agree. It made things much easier. Thank you.
Yeah.
Hey, Tim, what if I push my bot guy onto the other side of the board during double elimination? Can the other team get two bot guys?
The other team can score two bot guys. They cannot get two bot guy multipliers for their side, but they can get two bot guys.
All right.
We have another question about the mechanisms about the games. Is there any use of the scoring during the season?
Say that one more time.
So what, like, in other words, what role does the seeding game play?
Sorry, mine's like cutting out a little bit. Can you say it one more time for me?
Like say if we have like a high score in the seeding round, will it be useful to our double elimination?
So it's not necessarily useful in double elimination, other than it'll seed you higher in double elimination. But your seeding score comes out to be a third of your score. And then so your seeding in general is a third of your score. And then that seeding score is broken up into how well you did in seeding, and then like what the highest scores were in seeding. You can find that in the game documents. I think at the end is where it has those formulas.
So which document?
The bot ball game review. So the one that has all the rules and everything like that. I believe at the end of that document, there should be a where it shows a thing where it shows how those formulas work.
Oh, okay. Thank you.
Yep.
Any other questions? All right, Tim, I think we got all the questions. I don't see any more coming. So we're excited to see everybody in the morning. Again, we're going to see the Chinese teams at 8 o'clock Central Time, US time, and we're going to see the other American teams at 9 o'clock Central Time, ready to go with seeding rounds. So have your sunlight blocked and your batteries charged and ready to go. Anything else, Tim?
Not that I can think of. If you, for some reason, have not submitted your documentation yet and you were still planning to, at this point, either submit it in the form or just email it to me if you were having issues uploading it. and we'll make sure it still gets graded and everything. So.
Okay, Carol, do you have anything?
No, I'm good.
Okay. All right, well, I guess we will see everybody in the morning.
Good night, everyone.
All right, thanks everybody for joining. We'll talk to you later.
Thank you.
Bye.
Okay, see you later. Bye.
Yep.
Thank you. See you tomorrow.